Okay, today we are continuing on the subject of metals. Yesterday we would have covered the first few, which is how we state and explain the physical properties of the metals. And then we described how alloys are formed and why they have slightly different properties as compared to the metals. And lastly, we looked at the representations of metals and alloys in their structures. For today, we are going to look at the reactivity series. And in the reactivity series, we need to know that there are three types of reactions that we use in order to determine the order of the reactivity. Once we use these reactions, we must place them in the correct order. And finally, you must also memorize the reactivity series of the metals. Okay, so we'll now move on to the reactivity series. Reactivity of metals depend on how they lose their valence electron. The more easily they lose their valence electron, the more reactive we can say it is. Okay. So the position in the reactivity series we will determine by the reactions that we mentioned above, the reaction with water or steam, and the reaction with dilute acid. Okay, so the alkali metals, they are very reactive. They react with cold water. You remember that alkali metals are actually our group 1 metals. Moving on, when the group 1 metals react with cold water, it forms metal hydroxide and hydrogen gas. Okay, so this is the word equation for it. But for the metals that don't react with cold water, usually they need to heat it up to give it more energy. So they use steam, and instead of metal hydroxide, it forms metal oxide. Okay, so the key difference is that with water is hydroxide, with steam it forms oxide. Okay. In terms of reactivity, you can see that the terms that we use for the reactions actually come about from the vigorousness of it. So for example, potassium reacts very vigorously, it explodes with a lilac flame. As for sodium, it reacts vigorously, it may ignite, but it only has orange sparks. It will not explode like potassium. Yeah, I think we saw the video on group 1 metals before on how they react. Okay, for calcium, it reacts readily. There's no flame or anything. You will just see effervescence of hydrogen gas. Okay, by the time we reach magnesium, it will actually react pretty slowly with cold water. Okay, so the hydrogen produced is very little, and it produces at a slow rate. Okay, so what they need to do is they need to heat it up and react it with steam, and that will cause it to react violently with a white glow. Okay, for zinc and iron, you will see that again it gets less reactive as we go along. We need to make the steam hot, and the zinc and iron have to be very hot for this reaction to occur, and this indicates that they are actually less reactive as compared to the metals above them. The next reaction we look at is the reaction of metals with dilute acid, and this is something we actually learn in Sec 3 when we learn about the reactions of acid with metal. It will form a salt and hydrogen gas. Okay. So what you need to take away from this reaction is that you will see that the terms explosively, violently, rapidly, moderately, and slowly, all these are adjectives to describe how fast or slow it reacts, and you can see that it gets more gentle as we go from potassium down to iron. So this shows that the ones on top are the most reactive, and the ones below, they are actually less reactive. Okay. Going down further, you'll see lead, copper, and silver. These three metals, they do not react with acid at all. Okay. Here we have the reactivity series with two non-metals inside, carbon and hydrogen. Why carbon and hydrogen are in the reactivity series, we'll see in our next lesson about extraction. So how do we memorize the reactivity series? We use a memory trick called mnemonics, where we assign a letter for every metal. So for this mnemonics, please stop calling me cute zebra. I like him calling me sexy goat. The second C stands for carbon, and the H stands for hydrogen. The P, S, C, M, and so on, they stand for potassium, sodium, calcium, magnesium, zinc, iron, lead, copper, silver, gold. You have to be creative, because the more creative you are, the more personal you make it, it's easier to memorize. Okay, as mentioned earlier, the more reactive ones prefer to donate their valence electrons and form cations as compared to the less reactive one. So the more reactive one will have a greater tendency to lose electrons to form cations. Okay, so how does this work? It also has a displacement reaction. So for example, if I put magnesium metal into copper sulfate solution, you remember that copper sulfate solution is blue. Okay, so what we will observe is the magnesium being more reactive than copper, it will displace the copper out of solution, and you'll see copper deposits, solid copper. The sulfate in the end, right, it's just a spectator ion, it does not take part in the reaction at all. Okay, so you will also see that the blue color becomes colorless because magnesium sulfate is colorless. However, if you were to switch the position, if you put copper metal in the magnesium sulfate, there is no reaction because copper is less reactive, so it cannot keep the magnesium out. Okay? So to conclude, we can say that metals that are higher up will displace the ones that are lower, but the metals lower down will not be able to displace the metals above it. So for this MCQ, all you need to do is write down the reactivity series and use it to find the answer, which you'll find to be C. Okay, so let's try this question together. Okay, so let's take a look at the key information. Solution of iron sulfate is pale green in color. We are adding zinc metal into a beaker of iron sulfate. Okay, so what do we need to have in this answer? We need to have the observations in color. We need to mention any substance that is formed, and we need to write a balanced chemical equation. Okay, so we answer this right, we need to be very systematic. So first of all, the thinking process would be number one, you need to know which one is more reactive. So we know that definitely okay, so we know that zinc is more reactive than iron, which means that zinc will displace iron. Okay. So the first observation we see is, if zinc displaces iron, so if zinc is going to be displacing iron, what will we see is this pale green color will start to fade. Okay, so the pale green solution will turn colorless. Okay, so why this happens is because the zinc is now going into the solution to form zinc sulfate. Okay, and then the iron will be displaced. So what will we observe? We will see a grey solid iron form. Okay, that will be the formation of a substance. But where is it formed? In colorless zinc sulfate solution. Okay, the last part will be to include a balance equation. So what is the equation? We have iron 2 sulfate plus zinc metal solid, and what does it form? It forms zinc sulfate plus iron. Okay, so that's how we will answer this type of questions. Okay, for the last two examples, we are looking at displacement again. So which pair will result in a displacement? So for displacement to happen, you have to remember that the metal added in must be more reactive than the metal which is inside the solution. Okay, so again you need to compare with the reactivity series. Okay, so copper is less reactive, magnesium is more reactive than zinc, iron is less reactive than sodium. And for question 3, again you repeat the same thing, you just look at the metal and compare it to the metal inside the solution.